In this class, I'll be teaching you how to know the formulas for cylinder without actually memorizing them. So we have three of them. We have the curved surface area of the cylinder, we have the total surface area of the cylinder, we have the volume of the cylinder, and finally, I'll be explaining what it means for a cylinder to be closed at one end, open at one end, or when they say it's a solid cylinder. Before we go to explain how we derive those formulas, now we need to first understand what this solid shape is made up of. I mean the cylinder. If you look at it, it's quite obvious that for you to make a solid shape, the cylinder, you need two circles to make this cylinder. So I can say that a cylinder is firstly made up of two circles, right? And there's another last part, and that is this middle portion that I have here. So if I look at it, I will notice that it looks like this. This middle portion, it looks like this. Now, what is this shape? That's the next question I should ask myself. What plane shape is this? Because if I divide a part of this plane shape, you notice that it will spread out. It's like I'm breaking it into parts. So it's going to look like this. It's going to look like this because I'm dividing it. So if I divide this middle part, I will notice that this cylinder is also formed from a rectangle. Is also formed from a rectangle. So we could deduce that a cylinder is made up of two circles and a rectangle. A cylinder is made up of two circles and a rectangle. The understanding of this will simplify everything we'll be doing in this particular class. So that being established, that means that I said if I look at this cylinder, and that means when we talk about a solid cylinder, we are basically saying that a solid cylinder is that cylinder that it has two complete circles and a rectangle. It has two complete circles and a rectangle. So when they tell you that a solid cylinder, automatically it has two circles and a rectangle. Now let's explain first what we mean by the curved surface area. Curved surface area. So when we say the curved surface area, we're basically talking about the area of the rectangle. So curved surface area is the area of the rectangle. Area of the rectangle. So when they now tell you find the curved surface area of a cylinder, they are basically saying what is the area of this portion of the cylinder, that is, what is the area of this rectangle. And as well, when you are told that the total surface area, total, from the word total, is obvious that they mean the two circles, the two circles. So you are going to have the total surface area of the cylinder is going to be the rectangle, that is the curved surface area, and the two circles. So it will be circle plus rectangle. That will produce the formula for the total surface area. So follow me. So the curved surface area, we need to know what this is. We need to know what the total surface area is. So when you are told that a solid cylinder, just know that it means total surface area of a cylinder. And when you are told that the curved surface area of a cylinder, you are basically talking about the rectangle. So you need to know that when you are being told that a cylinder is open at one end, look at it, open at one end, open at one end. That means that the cylinder is going to look like this. It has a bottom, it's closed, and the top is open. So to find the area of that particular cylinder that is open at one end, then definitely it's going to have only the rectangle and one circle. It's not going to be two circles. It's not going to be two circles. So also note that when they say the cylinder is open at one end, it's the same thing when they say the cylinder is closed at one end. Because it is closed at one end, then it is open at the other end. So we have a solid cylinder. We have when the cylinder is closed at one end or open at one end. So let's now go into deriving what this is, deriving what this is. Now let's consider the curved surface area of the cylinder, that is this rectangle. So the curved surface area, this rectangle that we have here. If you remember very well, you know the area of a rectangle. That's quite obvious. The area of a rectangle is what? Length times breadth. So I can say the area of a rectangle is LB, length times breadth. So understanding that the area of a rectangle is length times breadth, then I can find the curved surface area because I'm still going to use the same pattern. So if I look at this, you know that and you remember that this rectangle was formed from this. It was formed from this. This was the curved surface area that we splitted into this rectangle. So if I fold this rectangle back into something like this, I have something like the circumference of a circle, because any part of a circle, this is a circle, any part of a circle is called the circumference. So if you take a tin milk that is either open or closed, and you touch the top part, that is the circumference, and that's exactly what I have here for that particular cylinder. If I touch the top part, that's the circumference of the cylinder. So if I relate it with the length here, I will notice that this top part is the length and this side is the breadth. So this is the circumference, this is the circumference. So therefore I can say that the length of this rectangle is same as the circumference of this curved surface area. So I can say length is same thing as saying 2 pi r. Did you get that? So also, if I look at this curved surface area back, I said this is 2 pi r already. Then ordinarily I said yes, the breadth, because that's the rectangle. Now if I compare breadth can also be used simultaneously as the height of the cylinder. So therefore we can say that the curved surface area of a cylinder now is given by what? 2 pi r times h. So the curved surface area of a cylinder is 2 pi r h anywhere in the world. The curved surface area of a cylinder is gotten from the area of a rectangle. So when you're in the exam hall and you maybe forgot the curved surface area, you don't need to start racking your brain. Just remember that the curved surface area is formed from the rectangle, the area of the rectangle, length times breadth. And as we remember that length is also denoted as the circumference of the cylinder, the circle top of the cylinder, and then the breadth, the height. Then you have the curved surface area. So let's go to the total surface area of the cylinder. We have the total surface area of a cylinder. You remember that I said when you have the total surface area of a cylinder, it's going to be the two circles and the rectangle. So the total surface area of a cylinder is going to be TSA. It's going to be the two circles and the area of the rectangle. So if I'm to ask you the area of a circle, what's the area of a circle? Is what? The area of a circle is pi r square. The area of this circle too as well is pi r square, and the area of this rectangle, remember that we just did it now, that's length times breadth, and that gave us 2 pi r h. So what was that? 2 pi r h. So I noticed that this I can sum them together to give me 2 pi r square plus 2 pi r h. This that I have here is known as the total surface area of a solid cylinder, or just a total area of a cylinder. Now this, take it anywhere, this is the total surface area. Now you can be told that find the total surface area of a cylinder that is open at one end. So to be open at one end, that basically means that you only have one circle, like I said. So it's not going to be applicable that this one of the circle will no longer be there. What I'm going to be having here is going to be what? Pi r square plus 2 pi r h. So you need not to cram everything. So all you need to know is understand that a total surface area of a solid cylinder means every circle, the two circles and the rectangle. Then you know that you have pi r square plus pi r square, then the rectangle is 2 pi r h. Then you are done. You already know the formula. Then as well, open at one end or closed at one end is one circle that is involved, and the rectangle, that will be pi r square plus 2 pi r h. Now let's go to the last part, and that's the volume of a cylinder. Now, for the volume of a cylinder, you agree with me that a cylinder is more like a container that takes in things like our tank that we use in our various houses. So if I'm going to consider the volume of the cylinder, then basically I'm talking about the capacity, what it can take, what it can contain, what it can contain. So if you look at this, that means that I basically don't need the top part of this cylinder because I'm only talking about the capacity, what it can take, the intake. That means I only need that the under of the cylinder, I mean the bottom, should be covered with a circle, then the rectangle, that is the curved surface area, is still there. Now remember that when you talk about volume, you basically talk about, in physics, we deal with length times breadth times height. So volume in physics is length times breadth times height. Now if I talk about length and breadth, what am I talking about? I'm talking about area. I'm talking about area. Then we have area times height. So when we deal with the volume of a solid, then we need to consider the base area. So what's the base of this solid? I mean this rectangle that we have here, it's a circle. So what's the area of a circle? The area of a circle is pi r squared. Then what do I have here? H. So therefore the volume of a cylinder is pi r square h. In order to recap all that I've said, we basically treated what the total surface area of a cylinder is, the volume, and as well the curved surface area. So when we talk about the curved surface area, we need to consider the rectangle only, that is the middle part of the cylinder, and the rectangle gave us 2 pi rh multiplied by h from the length times breadth. And as well the circles, when we talk about the total surface area of a cylinder, we are talking about the two circles and the rectangle. That gave us what? 2 pi r squared plus 2 pi rh.